In this demonstration of Resolve Actions, we are going to be taking a look at an automated use case centered around infrastructure and networking teams. It's dealing with an alert letting us know that a hosted application, in today's example, a simple web application, has become unreachable. The automated workflow is going to respond to that alert, do things like automatically create a ticket, post some bidirectional updates back to the monitoring tool, and then get to work handling the remediation steps. But first doing diagnostics, triage, root cause analysis, and all of that to figure out what the issue is. The entirety of this automated workflow was built inside of Resolve's visual drag and drop designer using a host of pre-built plug-and-play integrations. First, let's take a quick look at our simple Azure-hosted web application. Not a whole lot to look at, of course, but for today's demonstration purposes, it certainly gets the job done. Now, you heard me say that the automated workflow is going to carry out a number of diagnostics and triage steps to determine the root cause of this issue and what needs to be fixed in order to bring the application back online. It'll look at things like misconfigurations, services or processes that may not be running, etc. Also doing things like ensuring that associated virtual machines are actually powered on. But what's actually going to be the cause of today's outage is something a little more sneaky, something called human error. Now, I've got a particular network security group in Azure up on my screen here, and I'm actually going to delete a firewall rule that's permitting inbound HTTP traffic to this application. And as you could guess, this is a misconfiguration. This should never actually happen. And yes, it is going to break our application. It'll no longer be accessible from the public internet. And if we head back to the application itself and do a refresh, we'll see that. Oh, and there we are. The application is no longer reachable here in my browser. And shortly, an alert will be generated for this. So let's actually switch to our monitoring console. In today's example, we'll be looking at BigPanda. We've got some older alerts on the screen here, but in a moment we'll see as the new alert pops on in, letting us know that this application is unreachable. And then of course the Resolve workflow will automatically be triggered and get to work. And there it is. The web application in Azure is unreachable. So we're starting over here at this reopen. Everything below that is from a previous iteration of that alert. And we can see that Resolve already intercepted the alert and even posted a link to the alert console here, letting us know we can take a look at the live play-by-play of everything the automation's doing in real time. I'll close that. We've also got a direct link to the ticket that was automatically created. So the intelligent Resolve workflow is able to do things like properly categorize, subcategorize the ticket, link the configuration item, as well as insert any other dynamic information from the alert into the ticket. Now let's start down at the bottom. The first note lets us know that the workflow is going to ensure that the Azure VM hosting this application is actually reachable via ping. It's going to check on the status of the web server service, in this example today, Nginx, and it's also going to assess inbound firewall rules present in the associated Azure network security group. It also included those direct links to the BigPanda alert and the Resolve audit trail execution log like you saw before. So scrolling on up, we can see that a ping check to the VM was successful. So a false positive check will now be performed. We can see that performing a simple HTTP GET against the application failed, right? So this is a legitimate alert, not a false positive. We'll now investigate the web server services. And if we scroll on up, that's precisely what we're going to do here. It looks like Nginx was stopped. Hey, maybe that's the root cause of our issue here. But of course, spoiler alert for all of you watching, you saw me sabotage those firewall rules. So we know there's something else at play. After starting them up again, we're going to take another look with an HTTP GET. And of course, as we all know, that is still failing. So we've actually pulled all of the firewall rules associated with the virtual NIC on this virtual machine. So we've done all that intelligence to find the associated NIC as well as the associated network security group, or NSG, and we see that we've got these two rules here, and there is no valid rule to permit that inbound web traffic. So we've gone ahead and added it, and now we're going to wait 2 minutes before attempting to access the web application again. And you may be wondering, well, why would the automation wait 2 minutes just to see if the addition of the rule fixes the issue? Well, we all know from the time that you make a change inside of something like Azure, AWS, GCP, etc., it's going to be a bit of delay before we see it actually reflected on the public internet. However, if we pull up those inbound security rules and do a refresh, voila, just like that, the once missing, now restored inbound firewall rule for that web traffic has been added back by the automation. And if we take a look and refresh our web app here, we can see that it has been restored. It is up and running. And heading back to the ticket, once those 2 minutes wrap up, the ticket will automatically be closed. The alert over on the monitoring side will be totally resolved as well, and we can see that that just took place here. The incident is now closed. Everything's back up and running. And if we head back to our monitoring tool, we can see that our alert was completely resolved. So this automation not only helped eliminate some swivel chairing, right, providing links within all the platforms so somebody doesn't have to go and manually correlate, okay, where's the alert for this ticket? Where's the ticket for this alert? All of it done very simply, as well as adding that link to seeing the live execution on the Resolve side. But we've also reduced so much potential for human error and the need to swivel chair to log into these disparate systems, check that this VM is up and running, check that services are running. Human operator doesn't have to go and pull service account credentials and potentially make a mistake just like the one I made when I accidentally deleted the firewall rule. So today's example shows what would otherwise be a manual playbook done completely autonomously behind the scenes, just like it should be for cases like this, something that's routine and totally automatable. And like I said before, the entirety of what we watched here today was built with all pre-built integrations, all out of the box, plug-and-play components from the huge host of pre-built content provided by Resolve Actions. As a last final piece here to top it all off, the automation, in an effort to ensure that really good communication is made throughout the team, everybody that needs to know that this incident happened and was solved for, the workflow has actually posted messages to a dedicated Slack and dedicated Teams channel like you see up here on my screen, giving us links to all of the relevant systems, right? A link to that execution log inside of Resolve, a link to the alert inside of the monitoring tool, as well as the ticket, including a little blurb giving a description of exactly what happened here. And that wraps up this demonstration for automatically handling an alert for a down application inside of Azure, the result of which was, well, a bad misconfiguration of inbound firewall rules.